So we're going to start out with the basic, and that's monomials, or monomials. A monomial is a constant, a variable, or a product of numbers. And the way I look at it is it's just one term. It's just one term. There's no pluses or minuses in it. So some examples might be the number 6. That's a monomial. You might see something that's like x. You might see x cubed. You might see something that's a combination of stuff. You might see 6y squared x cubed. These are all one term. You don't have any pluses or minuses between it to say this is term 1, term 2, term 3. A monomial is just one term. The big thing with one terms are the ones that have powers. And that's what we're going to talk about today. We're going to talk about the exponent rules when you're dealing with a monomial. So the first rule we have is something called the product rule. The product rule is, if say I have x to the a power, and I multiply that by x to the b power. That is not simplified because we can turn that into just one x value. And we can write that as x to the a plus b. So if you ever see something multiplied, has to have the same base. This is called your base. Has to have the same base. You can actually just add your exponents. So an example of that might be, let's say I give you y squared, and I multiply that with y to the 5th. Well, my simplified form would be y to the 2 plus 5, or just y to the 7th. So when you're multiplying them, you add your exponents. The next thing is, what happens if I take an exponent to an exponent? That's called our power rule. So that might look like, let's say I have x to the a power again, but now I raise that entire thing to the b power. I raise that to the b power. Well, that's going to be x to the a times b. So a power to a power, you multiply your exponents. So an example of this, using maybe those same numbers, let's say I have y squared, and I raise that to the 5th power. Now, if I have y squared times y to the 5th, it equals y to the 7th. But if I have a power to a power, we multiply it, and we have y to the 10th power. Those are the basic ones. We've seen those before, I hope. I hope you've seen those before, and hopefully this is at least a refresher. That maybe you couldn't have done it yesterday, but today you're just like, yep, I've seen that before, I can do it. Now let's talk about our quotient rule. What happens if we're dividing? So let's say we have, x to the 8th power, or a power, over x to the b power. Well, the way I look at it is, multiplication and division are inverses of each other. They do the opposite thing. So if multiplication turns into addition, what do you think division will turn into? Subtraction. It's the opposite. So we're going to turn this into x to the a minus b. Let's keep the same powers going. So let's say I have y. I'm going to change it to y to the 5th over y squared. Well, 5 minus 2 is 3, so this turns into y to the 3rd. Note, they must have the same bases. You can't just do this willy-nilly. They must be the same bases. It's got to be y. If this was y to the 5th over x squared, there's nothing you can do. You leave it as is. All right, the next thing we're going to talk about is the negative exponent rule. The negative exponent rule is crucial because it's a way to get rid of fractions, that we can turn things into it. What did I use? I think I used x to the negative a. Yes, I did. So let's say I see x to the negative a. And usually we're going the other way with this. Usually we're taking the fraction and we're turning into this. But if I have x to the negative a, this is actually in place of 1 over x to the positive a. So it depends on what I need out of that particular circumstance. Sometimes I want to write this as not having a fraction. Sometimes I want to have this as a positive a value. So x to the negative a is 1 over x to the 8th power. So, for example, let's say I have x to the negative 5, or y to the negative 5, I should say. Well, that's hard to do in our head. But if I need to actually figure this out, I would just turn this into 1 over y to the 5th. And now this is something I can do in my head. Say it's 2 to the 5th. I can do that and do as 1 divided by it. The last thing is the zero exponent rule. What if I take anything to the 0th power? It's a trick question. It's 1 usually. So x to the 0th power is 1. There is a rare occasion when you have 0 to the 0. I'll put that as a little FYI. 0 to the 0th power is undefined. I'm not going to throw that at you. My job is not to trick you into questions. Basically, anything to the 0th power is 1 minus 0, but I'm not going to trick you and put that anywhere. We don't really write that. There's no reason to. So an example of that would be, can't really do a big example. Y to the 0th is 1. Or 6 to the 0th power is 1. Or 1,000,000 to the 0th power is 1. Or negative 1,000,000 to the 0th power is 1. Get rid of those 0 powers right away if you're doing a problem. All right, now we just got a bunch of examples. So that's going to be the hard part about this. If you know this stuff, it'll be more tedious than anything else. Because you'll be going through the homework and I got this, but we got to keep that practice going. So the first one is we have negative 6 to the 4th. Now this leads us to a big thing that we have to keep track of. This right here is different than this right here. Negative 6 to the 4th is 6 times 6 times 6 times 6. And then we tack on the negative after it because it's not in the parenthesis. This is in the parentheses, so this is negative 1/4 times negative 1/4. So what happens if I have a negative times a negative? It becomes a positive. So be careful, because this almost looks like it should be a positive. If you raise a negative to an even power, it turns it positive. So if this was negative 1/4 to the 8th power, it would be positive, whatever answer is. But the fact that this is not in parentheses, that negative is not affected by that exponent.
So it just goes in afterwards.
It goes in afterwards. So what you do in your calculator is you do 6 to the 4th power, and then you tack that negative on there. So that negative has to stay. Now, it's a good idea to maybe have calculators out for this. You can use your phones. But bring a calculator so you get used to this, because you won't be able to use a phone on a test. On the test, for these problems, it's going to be nice to have a calculator. Especially because maybe we know 6 to the 4th. Maybe we could do it in our head. But how much easier is it to just go 6 to the 4th on a calculator? Way easier. And can someone tell me, what is 6 to the 4th? 1,296. Do we agree with that? Okay. And we have that negative out front because it was out front. Now we have negative 1/4 squared, which will make it positive. And it should be a positive 1 over 16, correct? Am I good so far?
Yes.
Okay. Now, this is actually just a fraction. This is negative 1,296. Yeah, Jason. Okay. Oh, I thought I saw over 16. Does 16 go into 1296? Here's an easy way to do it. Plug it in your calculator.
81.
Say that one more time.
79.25.
79.25. And we got 81 as well.
It's 81. No, that's
And we got 18. We got a lot of answers.
81.
81, okay.
It's 81.
It should be negative 81. Just double check your calculator presses. All right, we got that negative 2 out front. We got this negative 1 here. Maybe before I do this negative 2, I do what's inside the parentheses. Because a negative exponent is hard to do until you just have a number. Because we know it's 1 over. And I don't want to put this as 1 over all of this to the negative. So let's do the inside first. The first thing I'll start with is 5 to the 0th power. That one's pretty easy. That just equals 1. So we have, in parentheses, we have a 1 over, but this is where we got a little trickiness here. We have 3 to the negative 1. So that's going to be what? 1 over 3 to the first power, or just 1 over 3.
that?
Oh, we can absolutely simplify that. Because right now we have 1 over 1 over 3. If I do keep change flip, it would just be 3. Because we keep the 1, we flip this to be 3 over 1. So 1 times 3 is 3. So then we have 3 to the negative 2. We tracking on that? Yep. The negative just means put a 1 above it. So we have 1 over 3 squared, which should equal 1 over 9 probably. Just in case we're not doing 3 times 2 and we're doing 3 times 3. It'll happen. It'll happen to all of us. Are we good with that? I'll show you a different way to do this. So let's play devil's advocate. I'll put it in a different color. I'll put it in red. Because there's no addition or anything, you can basically distribute this to both of those. And when you raise a power to a power, you use multiplication. So another way we could have done this is we could have written the top as 5 to the 0th times negative 2 all over 3 negative 1 times negative 2. I know I'm kind of sloppy there, but we're basically multiplying that negative 2 by both of those powers. Well, this will give us 5 to the 0th over 3 squared, which would be 1 over 9. Is any one easier than the other? I don't think so. I think maybe it looks like this one has less steps, but it has a lot more little notations that you can mess up on. So a lot of these are kind of choose your own adventure. Just get it correct. All right, let's go down to, should we do 3? I don't know how many we have. Let's do 3. Sure, thanks. All right, so the first thing I might want to look at is, do we have parentheses on anything? No. So this, to the negative second, only affects the p-value. It only affects the p-value. So we're going to have a negative 3 hanging out there. And that p is going to turn into times 1 over p squared. Times 8 to the p to the 6th. Now let me once again preface this with you could have did this differently. When you multiply the same things, you can just add these. So we could have just had p to the 4th. Just kind of depends on how you look at it. Can we all look up there and see that? Trying to help you. There's multiple ways depending on how you do it. I'm going to do it this way. Okay, so we have this negative 3 is going to go on top. This 8 is going to go on top. So we'll have negative 3 times 8. Negative 3 times 8 is going to be a negative 24 p to the 6th all over p squared. Now, what I'm looking at here is they have the same power here. When they have the same power, you subtract. So you're going to have 6 minus 2, which is going to give you 4. I'll do both steps. So this is actually negative 24 times p to the 6 minus 2. That whole thing equals negative 24 p to the 4th. If you wanted to do it a different way, if you want to write it down, you can notice that these are multiplication. So what I'm actually picturing is I'm picturing manipulating this to be negative 3 times that 8 times that p to the negative 2 times that p to the 6th. Now I have everything together. Negative 3 times 8 is negative 24. When you are multiplying, this will turn into p of negative 2 plus 6, which will give you negative 24 p to the 4th. Do I necessarily think any one of them is easier than the other? I don't. But it's just what's easier for you. What do you see first? And a lot of these have to do with what do you see first. For me, I saw the negative 2 before I saw the multiplication. But for you, you might say, oh, I see the multiplication first, so I do that way. Yeah. Yeah. All right, our next one. Let's get rid of this first. let's get rid of this first, realizing that we have some subtractions that we can do. The first thing I'm going to look at is 57 over 3. Does 3 go into 57? We can check with our calculator. Yeah, how many times? 19. 19 times. Yep. So that's going to be 19. Then we're going to look at this x plus 4 and this x. Now remember, x has a power on it. It has x to the first. That is x to the first. Well, x over 4 over x to the first is 4 minus 1, which will be x cubed. So that'll be x cubed. Our next one, I don't know if I did all the steps. I did. Okay, so our next one is going to be y to the, I'm going to write above this in a second. Let's take green. Let's go green with it. What's negative 2 minus negative 3?
1.
It equals a positive 1, right? It actually equals a positive 1. So we have y to the first because, and I'll maybe put that in there just for our notes, that negative 2 minus a negative 3 does equal a positive 1. And then we have minus, let's change that back to black. Minus 11x cubed y. Here's where we be careful to see if we can combine these. See this x cubed y to the first? X cubed y to the first? Are they the exact same?
Yeah.
Yes. So we can then add the numbers that are in front of it. So we can do that 19 minus 11. If anything was off, if this was x cubed y to the first and this was x cubed y squared, couldn't add it. They have to be exactly the same. So we have 19 minus 11, which is going to equal 8. X cubed y to the first. Are we okay?
Yep.
Okay. Do you just want to skip to the hard one down there?
We go back, sorry.
Yeah, absolutely. As long as you understand what's happening.
Thank you.
Yeah. What I think I'm going to do, just because we're all at different places, I think I'm going to skip to the last one, and then if we have time afterwards, I'll go back to the other two for people that need the extra support. But I know some of us are looking kind of bored, we're looking at your homework. It just depends on where you are. Okay? So we'll skip to that last hard one. And then if we have time, we'll go back to the other two problems. All right. So that very last one, probably the toughest of the bunch because you had a lot of stuff going on here. Now, we have lots of stuff we could do. You could distribute this 2 to everything. What I'm going to do is probably stuff in the parenthesis first. I'll do the stuff in the parenthesis first. Actually, this really isn't the hardest one. But anyway, so what I would tackle is let's keep that parenthesis around and let's look at this 39 over 24. Now, either I can do that full division or I can at least simplify it. Can we simplify 39 over 24?
Yes.
13 over 8.
Yeah.
I think it's 13 over 8 would work. Yeah. So we can actually do 13 over 8. Did you guys know your graphing calculators can simplify fractions for you if you ever bring them in?
Wait, what?
Your graphing calculator can simplify fractions. If you have yours in, type in 39 divided by 24. Did it give you a decimal out? Then go to your math button. So on your top left, it says math. Click it, and then you'll see, let me look at it real quick. You're going to hit enter under fraction. And you'll hit enter again. And it'll give you your simplified fraction. So you can decide very quickly if you want the decimals or if you want a fraction. So we get 13 over 8. All right, I'm going to put this in your court. C to the 7th, c squared is going to be?
C to the 5th.
It's going to be c to the 5th. Yes, what's your question?
When we simplify that, does that have anything? Does that change the exponent?
Nope, we haven't touched the exponent yet. All right, so you agree that c to the 7th, c squared, that equals c to the 5th because we subtract. Can someone help me with the d values? What's the d going to be? It's going to be d to the -1. That's the wrong color. Let's pick maybe blue. So d to the 4th divided by d to the 5th. We subtract 4 minus 5 is d to the -1st. And this is all squared. Now, maybe before I deal with this negative, I just kind of distribute that squared to everything. That's one way to do it. You could flip this, turn into fraction. It's up to you. What makes sense to you? I'm going to go ahead and I'm going to say, okay, that squared affects everything. So in a result, we're going to have 13 over 8 squared. We're going to have c to the 5th squared. We're going to have d to the -1st squared. 13 squared, that's 169, right?
Yes.
Yeah, okay, so we have 169 over 64. C to the 5th squared, is that c to the 7th? C to the 5th squared, is that c to the 7th because you add them? It should be 10, we should multiply them. That should be 5 times 2. So a power to a power is multiplication, so we'll have c to the 10th. And then we're going to have d to the -2. Yeah, be careful about the directions. Sometimes they'll say they want fractions or they don't want fractions. So in this case, it'd probably say simplify so you can have no negative exponents. So negative exponent, like you said, to get rid of a negative exponent, we just put it on the bottom. So this is going to equal 169 over 64 times c to the 10th all over d. Oh, d squared. Ooh. Almost a big mistake.
Oh, you put it underneath. Oh, because of the one.
Yeah, the 64 can go down there too. So there's two ways to write this. You can write this with the 64 up there. I'd be okay with it because you made a positive. Or you could have written it as 169 c to the 10th all over 64 d squared. And this most likely would have appeared because you turned this into 1 over d squared and you multiplied across. Both of those are correct answers though because you got rid of the negative. I'm okay with a fraction in there. Questions on a problem like that? Good so far? Okay, the only thing we have to really do now is we're going to name some stuff. I'm going to make our homework a little easier. I was just thinking about it, and I don't care about classifying as much. So first of all, polynomials. Polynomials, that's when we have pluses or minus. Where we have like a highest exponent of the polynomial is called your degree. And your standard form is always your biggest exponent first. So it is right exponents in descending order. In descending order. Just write them in descending order. So biggest power comes first. Second, so if I have a square, it'll be like x squared minus x minus a 6. Now, when you classify things by degrees, looking for my examples here, we could have a constant. There's no degrees. There's no degrees, that would be our constant. Just make sure all my examples are the same. I just picked 2. You can have something called a linear equation. Linear equation comes from the fact that it makes a line. Linear. That'd be maybe x plus 2. So we'll go up a power, we'll keep the 2, we'll just add an x. We have x to the first power. Then we're going to have a quadratic, which we focus on a lot. Quadratic, if I add it to this, we could go like x squared plus x plus 2. Then we have a cubic. Cubic, we're going to have maybe x cubed plus x squared plus x plus 2. And the last one we're going to talk about in this class is going to be a quartic. Let's just go x to the fourth dot, 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 dot. So that's one way to classify it, is by the power that you use. You can also classify by how many terms you have. If you have one term, we already talked about that. That's a monomial or a monomial.
Are we going to be graphing these?
In the future, we will be. It's going to be frustrating.
The fraction ones.
Well, we're not going to do super hard. Yeah. Oh, the rational ones.
Yeah.
The ones where you have. I have a.
Like the.
Yep.
Goes up and
I have a nice Bubblebot needs to see. It'll help you out. All right. So we have a monomial. If we have two terms, 2 by binomial. Three terms, 3 trinomial. There are other names, but we don't use them a ton, so we're just going to go with, if it's bigger than that, we'll just call it a polynomial. In fact, most of the time I just call them all polynomials. All right, I'm about to make your homework a little bit easier, because just thinking about it, I'm just like, I don't really care that much. This says simplify, write your answer in standard form, and then classify. You don't need to classify. If you want to, you can, but we're just not going to classify. Yeah. No, but on your homework it'll say classify, and you can cross it out of your homework too. So the last thing we have to do is just add and multiply, and we're done. All right, that's our pretty basic kind of unit right now. All right, so adding them. You just find things that have the common power, so b squareds and b squareds can be added together, our like terms. So our first like term would be this b squared and this 8b squared. Now, why am I not worried about this parenthesis? Let's talk about that first.
it's just separating them.
I have a parenthesis, it's separating them. But what happens if I distribute this positive sign? Does that change anything? No. So really the parenthesis just disappears. If you have a negative sign between it, does that negative affect all the... That's when you have to worry about the parenthesis. But when I'm in my head, I'm just picturing that plus doesn't do anything to it, so I'm just going to pretend like the parentheses aren't there. All right, that plus has nothing to do with it, so those parentheses aren't there. So I can just do our 8b squared plus b squared, which equals 9b squared. We'll go to our next one, which is our 5b. It's a positive 5b minus 2b. I believe that would be a 3b, unless my math is terribly wrong today. And then finally, we're going to have a negative 11, a negative 7, negative 11 minus, plus, because it's plus, right? Because we're attached by that plus. So we're going to have a negative 18. That would be, if I asked you to classify it, that would be a trinomial. It'd also be a quadratic. This would be a quadratic trinomial. So I'm going to say it. If you want to write it down, you can. I'm not going to really test you on it, though. Okay, so my next one. I should note that I already pointed out that there's a negative sign between there. So you can either in your head realize there's a negative sign. So I can go negative 3y squared minus y cubed plus 3y cubed, negative 2 minus 4y squared. But for more of you, it might be more useful to distribute that negative and then go from there. So for people that make simple mistakes, which I do all of the time, I would probably just distribute that so I'm not constantly thinking about it in my head. The first parenthesis disappears because it really is a positive in front of there. So that just disappears. We're going to have negative 3y squared plus y cubed minus 2. We're going to have a negative y. We're going to have a positive 3y cubed. And we're going to have a negative 4y squared. Now, I should probably find the biggest power, so I don't have to I can just do it once. So our biggest power looks like a cubed. Our biggest power looks like this cube, so I'm going to find the other cube that appears. It appears here. So I have y cubed plus 3y cubed, which equals 4y cubed. Now I have it in order, so I do want it in descending order. Then we have a squared. So we got this negative 3y squared. I have a negative 4y squared as well. So a negative, we're going to have a negative 7y squared. I am going to notice that I do have a negative y right there. It doesn't match up with anything else, so I'll just carry down that negative y. And the only thing left over is a negative 2. Yeah, should be kind of basic stuff, right? Just kind of tedious, if anything.
Yeah, very tedious.
All right, then we're going to simplify by using multiplication. We'll simplify, we'll write our answer in standard form, and then we'll be done. So no classifying. I do go in descending order of difficulty. Now, I told you guys I don't really do like FOIL or anything. I just take that first term and distribute to everything. Then I take the second term and I distribute to everything, and then I simplify from there. So, for example, I take this x and I multiply it by that 2x. That's going to give me 2x cubed. I'm going to take that x, I'm going to multiply it by that 6x, which will give me 6x squared. And then finally, I'll take that x times that negative 7, which will give me negative 7x. Easiest way to do this. Then I take that next term and I do the exact same thing. I most likely write it underneath. So I'll do something like, do that negative 3. It's negative 3 times 2x squared, which will give me a negative 6x squared. We'll have negative 3 times 6, which is going to be a negative 18x. And finally, I have a negative 3 times a negative 7, which gives me a positive 21. Now we just smoosh together our like terms. There is no like term for 2x cubed. There's just one x cubed, so we'll write 2x cubed. We're going to have, it looks like these actually cancel out, because I have this positive 6x squared, this negative 6x squared, so those just cancel out. Then I have this negative 7x. I have this negative 18x. Negative 7x. 18x will be a negative 25x. And then finally, I'll have a plus 21. Try the next two. Do the next two. And if you think you can't do number 13, I'm just looking for the next two. I'd like to go through 13 as well. Several minutes. On like a test or something, I would expect to have like this one done and this one mostly done in the time I gave you. This just kind of gauges where you're at with your skills and how much practice you need. So I'm going to run through 11 as quickly as possible because most of us have it done. I'd rewrite this as 4j minus 7k times 4j minus 7k. I'm going to use my method where I just distribute the first term first. 4j times 4j, that is 4 times 4, which is 16. J times j is j squared. Then when I distribute this 4 times this negative 7, 4 times negative 7 is a negative 28. J times k is just jk. Now we move on to the bottom one. That is our negative 7k. Negative 7k times 4. Negative 7 times 4 is a negative 28 again. We do have k times j, but I'm going to write it as this jk. So they match. J times k is the same thing as k times j, so I'm just going to write this as jk. And then finally we have a, and this is the most missed thing I saw out there, a negative times a negative is a positive 49. And that'll be 49k squared. Now, the official way you should write this is you should write the biggest power first and then descend that order. So we have a j squared followed by a j to the first. We'll have negative 28j, it'll be negative 28 plus negative 28, which is a negative 56 jk. And then we'll have that plus 49k squared. So it is descending from j squared, and then we have to throw that k squared in at the end. That is traditionally how you'd write something that has two squares, that you put the squares on the ends. Questions on that? Okay, our next one is just a trinomial that has, so this is just an exercise in patience. Trinomial times a trinomial is an exercise in patience, where I take that first term and I distribute it to everything in the next thing. So I have p squared times p squared, which should be p to the fourth because you add them. Then we have p squared times a negative 2p, which is a negative 2p to the third, because you add your powers. 2 plus 1 is 3. Then we do p squared times 1, which equals p squared. We have to do that 2 more times, because now we have to do that with this p value. I'll change my colors so you can see what I'm doing. So I have p times p squared, which gives you p cubed. P times negative 2p is negative 2p times p is p squared. And then finally, you're going to have p times 1, which equals p. These are the worst because we have to do it 1 more time. You have to do it with the 6 now. So we'll take that 6. I'll go underneath. And remember, it's a negative 6, so a lot of times I will actually circle the negative 6 so I can keep track of that negative. I have negative 6 times p squared, which is going to give me a negative 6p squared. I'll have that negative 6 times a negative 2, which is a positive 12. So positive 12, but I have a p left over. And then finally, I have that negative 6 times that 1, which will give me a negative 6. Are you okay with me letting you simplify that? I'll give you the answer. I'll just put a dot, dot, dot. And you should end up with, if done correctly, you end up with p to the 4th minus p cubed minus 7p squared plus 13p minus 6. Does anyone have it done and can collaborate that this is correct?
Yeah.
It's good? All right, cool.
It's so long though.
I know. It's just an exercise in patience. Here's the good thing about, hey, picture this on a test. I have to give you enough time to finish it, right?
So it's just
But is it a hard problem?
no.
No, but I have to give you time to do that problem. So it's tedious, but it's stuff you get correct. Yes?
Is it okay if we just like do the first term that we multiply? Can we do like a row? Do it like row by row?
Oh, I don't care. Just make sure you get it correct, okay? Yep. I don't care how you organize it. A lot of teachers do lots of different ways to organize it. Some will do big boxes that they put all the things in. This is just the way I do it. However you want to. We're in pre-calculus. Get the right answer. Okay, other questions? Okay, then I just like talking about number 13. It's not necessarily a hard question. It's just a question in what I should do. Now, you could take this and multiply it by everything, but we have to keep track of multiplication. So what I do instead is I just focus on one multiplication first. So I do like this. Let's box that in. Let's say I'm just going to simplify that. That's all I'm going to do. I'm going to simplify that, and then let's throw that on at the end. Okay, so let's just simplify that, or you could simplify the other two as well. It's up to you how you want to do it. Okay, so simplifying this means I'm going to take 2v times 2v. 2 times 2 is 4. V times v is v squared. Take that 2v times that negative 3, and I have negative 6v. Then I'm going to take that 3 times 2v, which equals a positive 6v. That looks like a y. And then finally I have 3 times a negative 3, which gives me a negative 9.
Would that be difference of squares?
Those would be a difference of squares, because what happens here is these cancel out, and suddenly I have 2v squared, which is 4v squared, minus 3 squared, which is 9. And now we have this times this. Yes, so I'm glad you pointed. That's difference of squares. We didn't have to do any work, right? We could have just squared this, which turns into 4v squared. Square that, it's 9. Difference of squares. And then if you do this multiplication correctly, you should end up with a negative 12v to the cubed, should be, plus looks like 4v squared plus 227v minus 9. Okay, so are these tedious? I agree. There are a lot of little steps you got to keep track, but here's the optimistic part about this. I put these on tests and quizzes, and I have to give you enough time to finish them.
So they're just all gonna be easy and long.
Well, like these ones. We'll get to more difficult ones tomorrow. Any questions on any of that? So we got plenty of time to start our homework. Here's the good thing in this section. We're all at different levels of understanding this stuff. But you also have 2 or 3 people that you can work with to help you understand the material and me to ask questions. Let's not waste time in class. These homeworks you can tell are going to be like longer and tedious, not necessarily longer, but let's get as much as we can do in class so we can ask questions. Maybe look for interesting questions and start with those. Maybe don't do the first couple. Maybe find ones that are more difficult and try those first. Otherwise, the rest of the time is yours to work. Yeah.
So if it's in parentheses and it's negative and you square it, stay negative?
Yeah, so if it's to an even power?
So like this one will stay negative, this
No,
one
yes,
won't.
this one will stay negative. Yeah, that one will turn into a positive. Yes. And it tells you how to enter in your calculator. So this tells you to do 9 squared and then tack a negative onto it. This tells you plug in negative 16 and square it.
Gotcha, I shouldn't want to get
Yep.
confused.